viewers, welcome to my channel. I am Instructor Allison. I would like to introduce you to the concept of limit. Don't worry, I will not bug you with the mathematical jargon that relates to limit. I'm going to go straight to the point. But firstly, if you're new to the channel and you've not subscribed to my channel, please hit the subscribe button and also make sure that you turn on the notification bell so that by the time I upload new video, you always get notified, all right? So, limit can be written as lim. That is to say, the short way of writing this limit is lim. But the mathematical expression of it is lim x squared. I'm setting an example as x tends to 0. So what does this mean? X tends to 0. The symbol here stands for tends to. Or you can also call it approaches. So this means x approaches 0 or x tends to 0. So here we can read it as limit as x tends to 0 of x squared. So that's how we read it. So we can have different functions. But what we'll be concerned about is whether x is tending to 0 or x is tending to 2 or infinity or any of that. And if it tends to any of these parameters or these numbers or as the case may be, what is the thing we need to do? What are the methods involving this limit that we need to apply in order for us to solve problem? So that is what I'm going to guide you through. So pay attention as we are going straight to that. As x tends to 0, meaning that in a graphical representation, if I have this to be the 0 point, and then we have from there, from this point to this part, the negative, this part will be the negative, the positive, and then a graph of this kind, x squared, could be something of this sort. So if x is tending to 0, what do we mean by tending to 0 is either it's coming from this direction moving towards 0 or coming from this direction moving towards 0. All right, so that is how, or the best way we can easily tell what approaches or tends to could be. But there are other mathematical relations to it, but in this video we're going to concern with the necessary parameter that will help you or guide you to pass your exams that relates to limit. So let's go straight to the point to discuss the method involving solving limits, after which we can be able to test some problems. So let's put it as methods involving limits. Or you can easily say the method used in solving limits. The first one I would like to introduce to you is method of direct substitution. All right, in this direct substitution, it literally means by the time you see x approaching either 2 or x approaching either 0 or 5 or any of the numbers, what you need to do is just substitute it into the value of x in the function or in the problem given. For example, if I have limit of x squared minus 2 as x tends to 4, what do we need to do? By direct substitution mean wherever you see x, you replace it with 4. Wherever you see x, you replace it with 4. So at this point, I will say 4 squared minus 2. And this is 16 minus 2. And the result there is 14. So this is the method, and this is the answer to this problem. So this is the method of direct substitution. That is how simple it could be. But in some cases, where you have limit of x squared minus 4 and all over x minus, okay, let's use 2 here as x tends to 2. What do we need to do at this point? By direct substitution, let's see what will happen. If I put in or plug in the value of x into these functions, I will have 2 squared minus 4 over 2 minus 2. And 2 squared is 4. 4 minus 4 is 0 over 2 minus 2 is 0. What does 0 over 0 mean? If you point it in a calculator, it will show you math error. This means meaningless. It doesn't have any meaning. So we call it indeterminate. The language we use for it in calculus is indeterminate. What is this indeterminate? It means it is meaningless. All right. So anytime you use direct substitution and you encounter such problem or such expression like this, it means that it is undefined, it is meaningless, it is indeterminate. So that means that method of direct substitution cannot work in that particular problem. It means you should try another method. All right, so that is what it is. There are different forms of indeterminate. I will talk about it also. So but let's try with the second method we can use in resolving limits, and that is the method I will put as factorization / simplification. In this method, let's set an example: x to the power of 2 minus 25 over x minus 5 as x tends to 5. So in such problem like this, by the time you try by direct substitution and plug in the value of x here, you can see that x squared, or which is 5 squared, will give us 25, and 25 minus 25 is 0. If you plug in 5 here, 5 minus 5 is 0. That is 0 over 0, and it's indeterminate. And because it is indeterminate, you don't need to, or you don't want to use that particular method. So you just have to try the second one, which is factorization. What does it mean by factorizing this? It's just about checking the numerator, because the denominator is okay already. The numerator takes the form of what we call difference of two squares. And you have a squared minus b squared. This can easily be written as a plus b into a minus b. By the time you expand this, you still have this. So in that case, this our x will represent a, which is x squared, minus this can also be reduced as 5 squared. You can see that these are taking the shape of this. All over the denominator is x minus 5. And I just explained that when you see something like this, you should place it in this format. So how do we place this in this format? It means that here we have x minus, or can put plus first, whichever one that comes first, there's no problem about that, minus 5 all over x minus 5. At this point, this x and x minus 5 and x minus 5 are similar, so they can easily cancel out. And if they cancel out, what is remaining is this. So you can write limit of x plus 5 as x approaches 5. So now we can try by direct substitution. Plug in the value of x, which is 5 plus 5, and the result of this is 10. This is how we use factorization, and we simplify it to get the value 10. I hope that makes a lot of sense. Please, if you're enjoying this video, hit the like button right now. Just pause the video and hit the like button. And if you're not subscribed to the channel, this is an opportunity for you to just hit the subscribe button. Thank you very much, and drop a nice comment if you're enjoying the video. Okay, let's proceed to the next method. The next method I would like to introduce to you is the method called the L'Hopital's rule. In this method, L'Hopital's, this is the method of differentiation. What this method means is that when you see a function, differentiate everything you have there, and then you have the result. I've already solved a problem. I'll drop the link in the description of this video, so that by the time you want to get more understanding or more complex problem on L'Hopital's rule, the link in this video will just navigate you to that problem, and then you enjoy yourself. So this L'Hopital's rule is the rule of differentiation. If I have problem of this sort, limit of x to the power of 3 minus 27 over x minus 3. Yes, as x tends to 3. In this problem, we can decide to use factorization, and we can also use L'Hopital's rule of differentiation. But because we are treating L'Hopital's rule, let's try by L'Hopital's rule. So what does it mean? We have to differentiate everything we have in here. Differentiation of x cubed is 3x squared minus differentiation of 27 is 0. Why is it 0? Because 27 is a constant. Even if it is 3, it's a constant, is 0. Even if it's 1, 200, 500, any number at all, the differentiation of a constant is, they call them constant. Differentiation of constant is what? 0. All over, differentiation of x is 1 minus this is 0. And what we have here is 3x squared minus 0 is 3x squared, and if that divides by 1 is still 3x squared. So we have limit of 3x squared as x tends to 3. So at this point, we plug in the value of x here. So we have 3 into 3 all squared. And 3 squared is 9. And 3 times 9 is 27. So that is the method of L'Hopital's rule. We have used that to simplify this. If you want to try by factorization, I will leave the process here so that you can continue with that. When you see something of this nature, you can easily split it as x to the power of, this is difference of 2 cubed. So you can split it as s cubed minus 3 raised to the power of 3. It's difference of 2 cubed. And when you see that, the process is just, if I have a to the power of 3 minus b to the power of 3, the same thing as saying a minus b into, let's use this space, a to the a squared plus, we have the remaining one to be ab plus b squared. So this is the expansion process. So by the time you use the formation of x and 3 in this process, you arrive at a nice answer. All right, so that is that. All right, the next method I will introduce to you is the method of dividing the numerator and the denominator by the highest power of the independent variable present. I'll be fast about writing it, dividing the numerators and the denominators by the highest power of the independent variables or variable present. And in this particular method, we use it whenever we see x or y or any of the alphabet tending to infinity. All right, when any of these parameters, it could be t, it could be x, it could be y, as much as it is tending to infinity, the method is to divide the numerator and denominator by the highest power of the independent variable. That doesn't mean it is the only method you can use, but you want to try using this to solve problem. So we're going to set a few, and I've also solved a problem relating to this. I will drop the link in the description so that by the time you navigate, you can see some complex problem on this method. So, but quickly, let's see a little problem we can use that to test run. I would like to introduce 2x squared, a quadratic function, plus let's say 3x minus 5, all right, minus x squared minus 2x plus 3 as x tends to infinity. So immediately you see this particular x, this expression, x approaches infinity or tends to infinity. Just try this method, dividing the numerator and denominator by the highest power. Now at this point, this is the highest power 2. Some cases you see, if it is a polynomial problem, you see the highest power to be 3 or highest power to be 4 as the case may be. That's what you're going to use. You don't have to involve the coefficient. The coefficient is not important here. So look at the solution to this problem. I will divide the numerator, look at it, by the highest power of the independent variable. This is the independent variable x squared plus 3x over x squared minus 5 over x squared all over. Also the denominator, I'm going to divide it by the highest power of the independent variable x over x squared plus 3 over x squared. So this is limit as x tends to infinity. What is the next step? I'm going to cancel out this. This will reduce one of these. This also will cancel out. This will reduce one of these. So what will be left here is just 2 plus 3 all over x minus 5 over x squared all over. Here we have just 1 remaining minus 2 over x plus 3 over x squared. So what will be the next point? We are going to do direct substitution. Wherever we see x, we substitute this infinity sign. All right, if we do that, so what we have now is going to be 2 plus 3 over infinity minus 5 over infinity squared all over 1 minus 2 over infinity plus 3 over infinity squared. But just take note that anything dividing infinity is 0. For example, 3 divided by infinity is 0. 5 divided by infinity squared is also 0. So what we have left is 2 plus 0 minus 0 all over 1 minus 0 plus 0. All of these that has 0 will disappear. So 2 divided by 1, the result is 2. You can see how we use by dividing the numerator and denominator by the highest power of the independent variable to solve this problem. And the last method is by rationalization. And that rationalization is when you see a problem that involves square roots, then it can just rationalize the conjugate. If it has a conjugate of that sort, you just rationalize it and then plug in the value of x. And there you go, you have the answer. So that is all from me to you about the introductory part of this limit, or the introduction of limits. And then I hope you like this video. If you do like this video, please make sure you subscribe to my channel, turn on the notification bell so that you receive the notification by the time I upload new video, and make sure that you hit the like button. Please hit it, because I'm sure you're going to enjoy this particular video. And please make sure you come back next time to watch my video. Thank you. I love you. Peace.